Hello class, welcome to Unit 10, Video 4. Today we're going to go ahead and look at common logs and natural logs. Your learning target today is that you can solve exponential equations using common logs and natural logs. So the first thing we're going to do is look at where these buttons are on our calculator. Okay, so using the calculator, evaluate each expression to 4 decimal places. So we have log of 3. So if you pull up your calculator, you need to find the button that says log. If you look, it's right here. Okay, so in order to do log of 3, you do log of 3 and hit enter. If you have a basic calculator, like a TI-34, I think they are, a little scientific calculator, they should typically have log on it as well. You just need to find it. And if you need help finding it, let me know. So log of 3 is point to 4 decimal places, so 0.477. This 2 tells me to keep the 1 the same, so 0.4771. Or sorry, 0.477, yeah, 1, that's what I said. All right, so 0.4771. Okay, let's go ahead and do log of 0.2. So log of 0.2. It gives me negative, and I'm going to go to 4 decimal places, so 1, 2, 3, 4. This 7 tells me to round the 9 up to a 10, which makes this 0, which rounds this to 9. So to 4 decimal places, that one would be negative 0.6990. Okay. Biggest thing to remember is that common logs are base 10 logarithms. Okay, so these are common logs. So it would be log base 10 of whatever number. Okay, we don't write the 10 because that's what the log means. If I want to use a different base, like log base 4, I'll write the number 4. But common logs are log base 10 of x, which we write as log of x. Okay, so they mean the same thing. So here's just a little example. If you do have the scientific Texas Instrument 30X or something like this, here's where your log button is. Okay, so you can do it on there as well. If you have the TI Inspire, I think, I can't see it, but it's right here. And I'm drawing with black, so there you go. So it's right there. All right, and on our 84, I already showed you where the log button is on there. All right, so I need you to go ahead and think back how we would solve for this problem. Okay, it's 3 to the x. Well, we would have said this is 3 to the x equals 3 to the third, so x has to equal 3. Okay, not all problems, though, are that nice. So what we have is other methods in order to solve problems like this. So I'm just going to move this over here. Okay, and here's the other way we can solve it. If you ever have a variable in the exponent, okay, if you have something like that going on, what you want to do is use a log to get it out of the exponent. So if you do log on one side, you always have to do it on the other side. And what the log, remember, the property is I can take that x and write it in front. So I would have x times log of 3 equals log of 27. Okay. Then to solve for x, I would divide, not by x, but by log of 3 on both sides. These will cancel, and so x is equal to log of 27 over log of 3. Okay, which if you type it into your calculator, make sure you end the parenthesis for this log, divided by log of 3, you should get an answer of 3, which you do, okay? So this one, you know, it's maybe a little bit more work to write it out like this, but if you can't ever figure it out how to solve something like in this way, you can go ahead and use logs, okay? If we look at our example 3, we have 3 to the x is equal to 11. Okay, well, I can't rewrite 11 as 3 to some power. It doesn't equal a nice number. We don't know what it is, but it doesn't equal a nice number. So if both sides of an exponential equation cannot easily be written as powers of the same base, you can solve by taking the log on each side. So let's just go ahead and do that. So I'm going to do the log on both sides. So I have 3x equals log of 11, which allows me to bring the x down in front. And I would divide both sides by log of 3 to get x by itself. So x equals log of 11 divided by log of 3. And I would type that into my calculator. And let's go ahead and round it to 4 decimal places. So log of 11, and make sure you see how it gives me this parenthesis, you have to end it, divided by log of 3. And I get 2.1826. Okay, if I'm rounding to 4 decimal places, this 5 tells me to round this up to 7. Okay, so my answer is 2.1827. All right, that's example 3. Example 4. Okay, I would say, can I write 42 as 6 to some power? Well, 6 to the second is 36, and 6 to the third is a much larger number. So let's just go ahead and solve it using log. So log on both sides, little log. That allows me to write my x down in front. So I have x log of 6 equals log of 42. To get x by itself, I divide by log of 6. So x is equal to log of 42 divided by log of 6. I go ahead and type it into my calculator. Log of 42 divided by log of 6. And I get the following answer, and I would round it to 4. So I'm looking here now at this 3. This 3 tells me to stay the same, so it's 2.0860 is my answer. 2.0860 is my answer. Okay. That is my answer for example 4. All right, so those are base 10 logs. Okay, they're base 10. All right, then what we need to do is talk about natural logs. Natural logs are basically just regular logs with base e. Okay, so they have log base e. Okay. E is a special number. It's like pi, okay? It has a value of 2.71828. Okay, if you're looking for it on your calculator, E is right above this button that says ln, okay? If I want to get to it, I would have to go second this, and if I want to figure out what it is, so first power, I would hit enter. Look at that, 2.718281828, and it keeps going on and on just like pi does. Okay, so E is not a variable, it is a number that has a meaning. Okay, so we have E. What we do is, instead of writing log base E, we write ln, which stands for natural log. Okay, so some people don't get confused. It's not an inverse. It stands for ln, which on your calculator looks like this. I'll probably write it like ln or ln, which might look like inverse, but it's the natural log. They switched the n and the l around, which is a little funny, but it is natural log, okay? Which can be found on your calculator right here. Right below log, there's natural log, which is ln. All right. Let's just look at where you could find this on your calculator. If you have this calculator, it's right below the log, okay? So it says, find the following using your calculator. So e to the second. E to the second. So there's e now to the second, and hit enter. There it is, okay? So that's how you'd find that one. Now if we wanted to do e to the negative 1.3, and I'm not writing these down, but I want you to check, can you type these in on your calculator correctly? Because if you can't, then you're going to have errors later down. So e to the negative 1.3 is 0.272531793. Okay? And then we have natural log of 4, so I would do natural log, which is right here, of 4. Okay, which is 1.38629. On this calculator, here's the natural log. Notice, once again, e is right above it. And natural log of 0.05. 0.05 gives me negative 2.99573. Okay. So that's how to use your calculator and finding those values. Okay, natural log, remember, is ln. All right, so natural base e. All right, we have e to the x. It's an exponential function, okay, and it goes to the order pair 0, 1, and when you plug in 1, it'd be 1e. The rule with our natural log is if I wanted to go ahead, if I had y equals e to the x, and I wanted to find the inverse, okay? If I want to find the inverse, in order to get rid of e, I would take natural log on both sides, and I'm going to solve for x, okay? The thing to remember is I'll have natural log of y equals. Now, natural log of e allows me to put my x down in front, so I'll have x. Now, natural log of e, they are inverses, so they cancel each other out. They're equal to 1. So I'd really have x times 1, so there's that. And it shows here, if I wanted to, that x is equal to natural log of y, which brings us to that e to the x and natural log of y are inverses, so they undo each other, just like multiplying and dividing do. Okay, so that's why they give you 1. So here is my e to the x function graphed, and here's the natural log function graphed. Notice how they're symmetric across the line y equals x. Okay, so the inverse of e to the x is natural log of x. All right, so biggest thing to remember is natural log of e equals 1. Here's our rule here. If I go the opposite, if I start with y equals natural log of x, and I wanted to solve for x, in order to get rid of the natural log, you take base e. So it's really e to the y equals e to the natural log of x. Okay, the e to the y is equal to, these will cancel, and I'm left with my just x. So x equals e to the y. So what I would just maybe make a note is that you take base e to get rid of natural log. Okay. So, example 5. It says, write an equivalent exponential or logarithmic equation. Okay, so if I wanted to get rid of e, I would take natural log on both sides. My rule is that this allows my x to come down in front, and these cancel, so I'm left with x equals natural log of 5. So there is a written in a logarithmic equation. Okay. Here, if I want to get rid of natural log, what did I do to get rid of natural log? Take base e. So it's really e to the natural log of x is approximately e to the 0.6931. Once again, that allows me to bring my x down in front. So I have x, and then e to the natural log is just 1. It's approximately e to the 0.6931. And if you ever forget, you can always go on your calculator and say second e to the natural log of, let's just say, 1. Okay, it should just come out 1. If I do the opposite, if I do natural log of e to the first, you should just get out, once again, 1, because they undo each other. Okay. All right, so that is example 5. Let's go ahead and look at example 6, which is another solving an equation. Okay, so in order to solve an equation, we always use inverse operations. Okay, so with 2x equals 4, we would divide, because division is the inverse of multiplication, because it's 2 times x, so to undo, we would do division. Here, we have something squared, so we would square root each side, because squares and square roots are inverses. They cancel each other out. With log base 3 of x equals 10, we would put it into exponential form, because logs and exponentials are inverses. Okay. And last one, the newest one, since e to the x and natural log are inverses, we will use them to solve equations. They undo each other. Okay. So number 6, I might just go ahead and rewrite this. Yeah. And do it on here. So problem 6, we have 5e to the negative x minus 7 equals 2. Okay, what I need to do is get my e all by itself before I can do anything else. So I'm going to first add 7. So I have 5e to the negative x equals 9. Then I'm going to divide by 5. I'm just going to leave it as 9 over 5. Then from here, in order to get rid of e, natural log on both sides. So these cancel, and I'm left with negative x equals natural log of 9 divided by 5, all of it. And then I would go ahead, in order to get x by itself, divide by negative 1. So x is equal to, positive divided by negative will be negative natural log of 9 over 5. Now let's type it into our calculator. I would have negative natural log 9 divided by 5, which gives me that x is approximately, let's just keep rounding to 4 decimal places, 5.587. This 8 tells me to round this up to an 8, so negative 0.5878. So number 6, this is also equal to negative 0.5878. All right, that is example 6. Example 7, okay? I would recommend pausing the video and trying this one. This one's very similar to one we just got done doing. Okay, so I hope you paused the video and tried this one. Here's how you would do it. Subtract 2 first. 3 to the EX equals 2. Divide both sides by 3. So I have e to the x is equal to 2 over 3. Now in order to get rid of the e, we would take natural log on both sides. So x is equal to natural log of 2 over 3. Or I can type it in, and x is equal to natural log of 2 divided by 3. I get negative 0.405. This 6 tells me to round this up, so 0.4055. Okay, so negative 0.4055. Okay, that is example 7. Moving on to example 8. Okay, we want to get e by itself. So first thing is add 9. So I have 4e to the negative x is equal to negative 2 plus 9 is 7. Divide by 4. Natural log on both sides to get rid of my e. Bring the negative x down from the exponent. So it's natural log of 7 over 4. And then I would divide by negative 1. So x is equal to negative natural log of 7 over 4. And if I type it in, we would have negative natural log of 7 divided by 4, which gives us negative 0.5596. Okay. If you have any questions about solving exponential equations, please let me know. Otherwise, we're going to move on to our last example. Okay. So when interest is compounded continuously, so whenever you hear the words continuously, the amount A in an account after T years is found using the using the formula A equals P times E to the RT, where P is the amount of principal and R is the annual interest rate. Okay, so the word continuous means you're going to use the PERT equations. Everybody see how it's PERT? It's an easy way to remember it. P times E to the RT. So PERT. So suppose you deposit $1,000 into an account. Okay, what is the 1,000? Okay, it's the principal. It's what you start with. So this is P in an account paying 2.5% annual interest compounded continuously. Okay, so 2.5% is the rate, but I would write it as a decimal. So point, move it twice, 0.25. Okay, so my equation would be that A is equal to 1,000 e to the 0.025t. So part A says, what is the balance after 10 years? So t is time, so I plug in 10 for my equation. So 1,000 e to the 0.02510. Okay, everybody should take their time and plug this in to make sure you can actually type it into your calculator. So we had 1,000 times e, so get our e, to the, okay, my calculator automatically puts it in the exponent. If yours shows a little caret and then gives you a parenthesis, you need to make sure you end the parenthesis after we type in 10. So you'd have to do 0.025 times 10. Okay, and if you have my calculator and you want to get out of the exponent, just remember you arrow over 1 and it'll go down. Okay, and hit enter. This is talking about money. So money, we do not round to 4 decimal places or 3. We only round it to 2. So this 5 tells me to round up, so 0.3 cents. So $1,284.03. So the amount is equal to $1,284.03. Decimal. Okay. That is part A. Part B says, how long will it take for the balance in your account to reach at least $1,500? Okay, well, that's when we want our amount to be. So our A is 1,500 equals our 1,000 e to the 0.025. We don't know t this time. That's what we're trying to find out. So I would start by dividing both sides by 1,000. 2 zeros cancel. So 15 over 10, it's going to give me 1.5. Now we use our skills for solving. Okay, I want to get rid of my natural log. Sorry, get rid of my e, so I would take natural log. So I have natural log, which is 1.5, equals, these cancel. This comes down in front, so I'm just going to write it. And my last step is to get t by itself, so 0.025 is what I need to divide both sides by. So my time is equal to natural log 1.5 divided by 0.025. So let's talk about how to type this in. Natural log 1.5. Then make sure you hit the parenthesis to close it off. Then you would hit divide by 0.025 and hit enter. And it's going to take 16.21. Let's just round this to 3 decimal places. The 6 would tell me to round this up to 9, so 0.219. And this is in my time is in years, I think. Yep, years. So there's my answer for example 9B. Okay, that is it for Unit 10 Video 4. Biggest thing to remember is that E and natural log undo each other. So if you have any questions about that or your calculator, please come and ask me. Otherwise, have a great day, and I will talk to you later.